Let's talk about the interesting case where we're trying to find the purchase price of a bond between interest payment dates. This is a little bit meatier. We get the opportunity to use all our skills that we've learned in the financial math component of this course, pour it all into one particular question. So we have a savings bond, face value of $1,000, bearing interest at 7%, payable semi-annually. So now we know how to calculate the coupon payment. Matures on November the 1st, 2016. What is the purchase price of the bond on August the 3rd, 2012? To yield, which aka the market rate, 6.2% compounded semi-annually. And we look and say, hey, when did the bond begin? I don't know. But guess what? I don't care. All we care about is the coupon payments remaining. If you're buying this bond, all you will get is the future coupon payments, not the past ones. Those past ones have been gathered up by somebody else. You don't get them. All you care about, future payments, because those are the ones that are going to come to you, and that's all you're going to pay for, is the future payments. So all we need to know is, when does this bond end? When does it get paid? How much does it get paid? What the face value is. Okay, so purchase price between interest dates. How do I know? How do I know it's different? Ooh, look at all those dates. November 1st, 2016, August 3rd, 2012. Once you see those coming through to you, days between dates, two-step process to calculate the price of this bond. Automatic. Just screaming right out at you. The question is just yelling in my ears. It's so doggone loud as to what I need to do. Okay, draw the timeline is what I really need to do, because there's a lot of moving parts in this one. Okay, so what do I know? I know that on November the 1st, 2016, two glorious things will happen. We'll get the face value of this bond back, and we'll get a coupon payment date. Also, I know August the 3rd, 2012, we're selling this bond. Date of sale. And we need the price on that particular date. Now, step one. Right? Look at step one. Market price of the bond on the interest date immediately preceding the date of the purchase. Okay. We have a nice little picture here, too, in the textbook. So we got date of sale. All right, step one, find the present value, preceding interest payment date. When the hell was that? Well, I know I'm going to get one on November the 1st. Right? We know that. And I get two a year. When does the other one happen? Okay, now I start counting on my fingers, right? December, January, February, March, April, May. May is the 6th month. That is the immediately preceding date, May 1st, 2012. And, of course, November 1st, 2012. The date of sale must fall between those two coupon payments. The one that's already happened and the one that is next to happen. Right? Notice the pattern. We're going to find the value of the bond on May the 1st. And the next coupon payment takes place on November the 1st. Okay? So it can be the situation where, does the date of sale fall between May and November? Or does it fall between November and May? This is very important. Does the payment fall between May and November, or November and May? Doesn't matter. But you need to keep track of it, right? The most immediately preceding payment happened on May the 1st. The next payment will happen on November the 1st. August the 3rd falls in between. The date of sale has to fall in between those two. If you're drawing out a picture and that date of sale does not fall between the payment that just happened and the payment that is about to happen, then the diagram has been drawn up wrong. Okay, and sad to say, I've seen all sorts of mutated versions of these timelines, but it's very important to keep the patterning here. Very important to keep the patterning here. I just cannot emphasize it enough. I'll say it 1,000 times. Some of you are probably going nuts already, saying, okay, shut up already. But I live in fear that the final exam rolls around and folks get that all mixed up again. Okay, so what's that bond worth on May? That's just a regular annuity, and I got the I, present values, what I want to figure out. Got my coupon payment, my face value, and my payment structure. And I think they're both semi-annual in this case, right? Yes, they are. Okay, so now I need to figure out how many payments are remaining. I only care about the payments left. Now, there is the long way to do this and there's a short way to do this. And because this is the first time we're doing it, I'm going to do it the long way. Okay, so I'm going to count. I got 2012, right? Okay, so I got one payment in 2012. And in 2013, I will have a May payment and a November payment. Total 2 payments. In 2014, I will have a May payment. I will have a November payment. In 2015, I will have a May payment. I will have a November payment. In 2016, the date this bond ends, on May the 1st, 2016, I will get a payment. On November the 1st, I will get a payment and the face value back. Total of 2 payments remaining. Okay. So far, we're all tickety-boo, right? Tally that up. 2, 4, 6, 8, 9. 9 payments remaining. Punch in the 9. I know it'll always be an odd number. If I go in semi-annual payments only, if I go from a November to a November, it means there's going to be an even number of payments remaining. But if I go from not a November to a November, I know there's going to be an odd number of payments remaining. I is the yield, 6.2, compounded semi-annually. Present value is what we're trying to find. Our coupon payment is, in this case, is 0.07 because it's payable, right? 7% payable, divided by 2 times by 1,000, and that equals to $35. And the face value is $1,000. So now I'm going to punch that all in just like a regular annuity, if you will, and then we'll spit out the answer. Give that a shot. I'll sit here patiently while you do that. Okay. Yeah, I know I'm not that patient. So we get present value, we get 10, 30, and we got a string of a lot of 9s here. I'm just going to keep all these decimal spots for no reason other than this isn't an intermediate calculation, and it's always a good idea to keep a lot of decimal spots for those intermediate calculations. Okay, so on the May the 1st, 2012, this bond is worth $1,030, 0.999706. Okay? Second step. Now, second step. This is where the really, really fun stuff begins. Okay, between May the 1st and August the 3rd, right? May the 1st to August the 3rd, the seller of the bond is accruing interest. Right? This is interest that is owed to the seller but not yet paid. Now, on November the 1st, 2012, whoever owns that bond gets the full coupon payment date. The bond issuer does not give a hoot about the buying and the selling of this bond. Okay, does not care. Okay, whoever's the owner of record on November 1st, 2012 gets the 100% of full coupon payment date. However, the seller says, whoa, from May 1st to August the 3rd, I held the bond. I should get that portion of the interest. Just like your cell phone says, hey, you used the cell phone from this date to this date, and even though, again, the bill's not due to November the 1st, you're still on the line if you happen to cancel it. On, let's say, August the 3rd, for instance, right? So you're still owing that money, but now it has to be something that's adjusted between the buyer and the seller in the market. Okay. So our first step is we need to know how many days did the seller own that bond. So how many days out of that next coupon payment period did the seller own the bond? So we're going to go visit our days between dates calculation. And we need to know the days between dates from May the 1st, 2012, to August the 3rd. Okay. And we're going to use our days between days function in our calculator. Okay. And we see that that's 94 days. Okay. So the seller owned the bond for 94 days of that period. The seller is going to be entitled to its share of that next interest coupon or coupon payment. We also need to know the days between dates for the entire period. Yes, I know it's semi-annually, and semi-annually is roughly six months, but we need to do something a little bit more precise than that, because we are often talking about some pretty big dollar amounts. And so the number of days, every 6 month period is not exactly the same. It can be as low as it can be as low as 181 days, as high as 184 days. Okay, this payment period happens to be 184 days long. Okay, so out of the 184 days, the seller is entitled to the interest from 94 of those, or you can think of it as a proportion. 94 184ths of the interest payment should go to the seller, and the remainder, 90 out of 184, should go to the buyer, right? We're just splitting it up so that it's fair. If you held the bond, you get the interest. If you didn't held the bond, you don't get the interest. Okay? So we have those two numbers. Now, to find the cash price, we do a little bit of compound interest. So we take the 1030, right, which we know it was worth, the bond was worth on May the 1st, right? And there's no coupon payment dates in this 94-day period, by the way. Otherwise, we wouldn't be doing all this work. And then 1 plus 0.062, right? The yield divided by 2, because it's compounded semi-annually. Okay. And then the exponent is 94 out of 184. Okay. Again, it's just a way of sort of apportioning the interest between buyer and seller of this bond. And then we punch this through. Give that a punch through. Make sure you can deal with all those exponents and all those moving parts. I'll wait patiently. Waiting patiently really just means I push pause. Doesn't seem to be patient to you, eh? And so we crunch that through, and we should get a value of $1,047, and we can round it here, 21 cents. Often it's actually not rounded. And so this is what we're looking for as the cash price. So if you wanted to buy that bond, this is what you'd have to pay in order to buy it. Okay. There's a couple other identities. This one's got all the labor involved in it, right? There's 2 steps, picture, and so on. Other things that are important to us is the accrued interest. Okay, sometimes I call that AI. AI is just a portion of that coupon payment that goes to the seller. Okay, the seller held the bond for 94 days out of the 184. Multiply by whatever that coupon payment was. In this case, it's $35. And so the seller, or the accrued interest, $17.88. Okay. So when we go to a quotation service to find the quoted price takes out the effect of the accrual, again, allowing for us to compare bonds more easily. And that just equals to the cash price. This is just by formula. We have the formula in the slides, minus that accrued interest. So that equals the 1047.21 minus the $17.88. And that gets us our quote 1029.33. Okay. So again, taking out the effect of the accrual, quoted price is $1,029.33. So anytime we're finding purchase price between interest rate payment dates, these are the 3 deliverables that are potential. We need to find the cash price, the accrued interest, and the quoted price. Okay. Cash price is the hardest one. Accrued interest is very easy. Quoted price is even easier. But cash price does require that two-step process. Life is a lot easier if you draw a timeline. There is no shortcut beyond the two-step process, and no need to invent new financial mathematics. This is pretty tried and true stuff. N is never a fractional number unless we're calculating N. There are no partial payments here in bond pricing, so it's not like you're ever going to get a partial coupon payment date. So N is not going, you're not going to be punching a fractional number in N when you're doing bond pricing. Hey, keep all that in mind. Thank you for listening.